Welcome back, and now we're going to kind of put everything together. So we know about augmented matrices, we know about row operations. Now we're going to put the two together with a special definition and see if we can solve a system of equations using a matrix. Okay. The ultimate goal that we want to get to, at least in this video, is getting the matrix in what we call row echelon form. And you're going to see different books represent this differently. You might see the symbol REF. Okay, if you see REF, lowercase in mathematics, that typically means row echelon form. Okay, and so when we talk about row echelon form, there are three criteria that we have to satisfy. So first, any rows that are all zeros, those just have to be at the bottom. Okay, that's rarely it happens. Okay, all other rows, when we think about the first entry of that row that is not zero, it needs to be a 1. Okay, we call that the leading one. Okay, that's also a little bit of important language, so pay attention to that. Lastly, and this is kind of the sticking point, is that after the leading one, or the leading ones that we look at in each row is to the right of the row that's right above it. Okay, so meaning that if we think about what it would look like is we would have maybe a 1 here, and then we'd have some numbers, and then the next row would have to have the leading one down and to the right. Okay, and then some numbers 0, 0, 1, that sort of thing. Okay, this I'll come back to this in a moment. We could also have the situation where it's like 1 and then numbers and then 0, 0, 1. That's fine because this leading one is to the right of that leading one. Okay, so as long as we have a leading one that is in between successive rows that is down and to the right, we're good. Okay, when we think about this, another way of representing this is that our main diagonal, which is from the top left and then down to the right in a single, like down one to the right one every single time, that's what we call our main diagonal. Okay, so we'll see that pop up later. Well, I'll say in a future video series. Okay, but that main diagonal, that's mainly what we want to check. We want to make sure that that is 1, and then everything above it, oops, let me undo that. And everything above that main diagonal is not 0, and that's what we call upper triangular form. Okay, you can kind of see that where that triangle comes from. So in that triangle, everything should be non-zero. Okay, if we have a main diagonal. All right, something that is not going to be in row echelon form is something like 1, 0, 0, something like that, and then 1, 1, 2, da 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 da, and then 0, 1, 3, da, da, da. This is the problem area. Okay, this would be considered your leading one, and it is not down and to the right of the previous leading one. Okay, so just make sure that when we talk about row echelon form, we have all those three criteria satisfied. And I kind of mentioned this in the previous in my previous example with something where we have a matrix that is in upper triangular form. We would just make sure that the main diagonal, I'm just going to put asterisks there, is non-zero. Okay, so this would be considered your main diagonal, and then below it you would have zeros, and then above it you would have non-zero entries. Okay, so these could be like 2, -1, 5. I don't know. I'm just filling up numbers, and something like that. Okay, so you can have numbers up in there. It's just that below that diagonal, you don't. Okay, now, how do these fit together? We're going to take the augmented matrices that we've been studying, okay, use elementary row operations on them to obtain a matrix that is in row echelon form. Okay, once we have it in row echelon form, we're going to use back substitution to solve the system. Okay, now this is a highly creative process. People can get to the same answer in a variety of different ways. So if you happen to solve it a different way than I do, that is perfectly okay. And you might wonder at several points in the examples that follow, why do you do it that way? Well, you don't have to. It's just what I saw. It's what I was thinking about. Okay, so this video is going to be divided into two parts. We have the general idea. The next video will we'll look at the two examples that follow.